Here's an example in which they're asking us to find the cosine of 2a, giving us the cosine of regular a. So you see what's going on? They want the cosine of the double angle, giving us the cosine of the regular angle, telling us it's in quadrant 3. So let's go to it. Step number 1. Draw your triangle in quadrant 3 from the origin to the x-axis. So we have got to make that happen first off. So I'm going to do it right over here. Oh wait, I'm going to do in quadrant 3. Here we go. So there's quadrant 3. So you go from the origin, not to the y-axis like that. That's a mistake. We have to go from the origin to the x-axis like that. Now why? Why do we have to go to the x-axis? This is the x-axis, this is the y. Because when they made the coordinate system, they started 0 degrees on the x-axis. They could have started it straight up. It was just random choice. But they started on the x-axis. So all of our angles really are from the x-axis originally. So we have to make our triangle go to the x-axis. The angle we're looking for, angle A, we're gonna put it right here, but really that's not A. I'll call that A reference. Really, A is from 0 degrees all the way to there. That's truly angle A, right? Angles really come from 0 degrees. So that's really angle A. When I say this is angle A right here, that's not really angle A. That's the reference. That's a small version of angle A, what we call a reference angle. The point is, because I made that reference angle from the x-axis, made it right coming from the x-axis because the triangle went to the x-axis, so therefore the angle's coming from the x-axis, it's going to have the same answers. It's going to have the same sine, cosine, and tangent as the real angle A, which really comes from 0 degrees, the real deal. That's why we have to go to the x-axis, so that our reference angles will have the same answers for sine, cosine, and tangent as the real angle, which really comes from 0 degrees. All right, so we use reference angles to find answers for the real angle, which comes from 0 degrees. This is really angle A here, and this is angle A reference, but the answers will be the same. Okay, step 2. Get 2 sides from our friends SOHCAHTOA. So let's do the SOHCAHTOA thing. So from A, angle A here, reference angle A, same thing. This is the opposite. This is the adjacent, and this is the hypotenuse. Okay, so cosine, remember SOHCAHTOA, cosine is adjacent over hypotenuse. So this must be adjacent over hypotenuse, right? Negative 36 over 85. Adjacent is negative 36 over hypotenuse, 85. Makes sense it's negative, right? Because starting from the origin, it's left and down. So that opposite side's got to be negative also, because we're in the third quadrant. Now, step 3, find the third side. How do we find the third side? From the Pythag, right? A squared plus b squared is c squared. So a squared plus b squared is c squared. C, ooh, I just hit the wrong button there. C is the hypotenuse, right? C has got to be this side here. So 85 squared. A squared and b squared is the other two. It doesn't matter which one you call A and B. One of them is the minus 36. The other one is just A or B. It doesn't matter. So a squared plus, use your calculator. That's a whopping big number. 1296. I could do it. You know, I really could do it in my head. I just hate to show off. So I'm using my calculator. I'm just joking around. I couldn't do it in my head. All right, not easily. So minus 1296 from both sides. So what do we get then? A squared is something. Minus 1296. That's it. Now I'm scribbling everywhere. Here, it's just, I just don't like how badly I wrote that. Here we go. Anyway, what does it come out to be? It comes out to be 5929. And then we're going to root it. Is that square rootable? Yeah, it's a nice 77. Wow. Okay, so that comes out 77. But careful, it's a negative 77, isn't it? Do you see that? Because again, from the origin, we're back and down the triangle to get to this point where our angle is the angle here, right? So to get to that point, you go back and down. So it's negative and negative. They're both negative. So you got to be a little careful there. All right, so watch your sign. So we found the third side. Now back to it, number 4. Now you find the sine of A and the cosine of A from, again, our friend SOHCAHTOA. So we've, the sine of A is opposite over hypotenuse. So here's the opposite. Here's the hypotenuse. So it's going to be negative 77 over 85. And then the cosine of A is adjacent over hypotenuse. So that's adjacent over hypotenuse. So that's negative 36 over 85. Of course, we already had it right here, huh? We just grabbed it from right there. So we did all that triangle work really to get our hands on sine. That's the thing we didn't have. So now we know the sine of A because of all that work we did. And it makes sense. A good double check is notice the sine and cosine are both negative. Does that fit with the memory device we know about called all students take calculus? All are positive in the first quadrant. Students take calculus, which means tangent and his reciprocal cotangent are positive in the third quadrant. The other 4 trig functions are negative. So yeah, sine and cosine should be negative in the third quadrant. Negative, negative makes sense. Okay, so good double check. Got our signs right. We're on track. All systems go. So step number 5. Find the double angles. Using the formula. So now we go get the double angle formula. What are we trying to find? They're asking us for the cosine of 2a. So the cosine of 2a form, we come down here to the formulas. You see it right there, cosine of 2a, cosine squared, right, cosine of double an angle is cosine squared of the regular angle minus sine squared of the regular angle. So, let's do it. Cosine squared of the regular angle minus sine squared of the regular angle. So what is cosine of the regular angle? Well, that's minus 36 over 5. We've had that from the beginning. So minus 36 over 85 squared minus the sine. Now that's the part we did the triangle work for to get our hands on that. Minus 77 over 85 squared. Notice they're both squared, so the minus negative part of them doesn't matter at all. We could have blown that and we'd still get the right answer. But if they'd asked us for sine 2a, it would have been a different deal. So anyway, let's square that 36 there. I'm getting 1296 positive, right? Because that square and that negative, we're going to square that negative. So 85 squared is 7225. Minus, and the bottom is going to be the same. Top, 77 squared, 5929. Subtract those. I think we're going to get negative. Negative 4633, 7225. And so there we go. We found the cosine of the double angle. We had to do a bunch of work with the original triangle and find the sine of the single angle, and then we could use the cosine of double angle formula at that point.